All right, today we have section 4.1 techniques for finding derivatives. So the past couple sections, we have talked about finding limits, finding instantaneous rate of change, and the formal definition of a derivative. Now we're going to get to the easy button, as I like to call it, the old Staples uh, commercial, easy button, boom, we're going to go straight to our answer. We ain't got to worry about no limits. We ain't got to worry about letting h go to 0. We're going to jump straight into our answer. So the first thing we want to talk about is some other notation that we can have. So the first one, f prime of x. Nothing different there. We've already been seeing that. Now it's still going to be what we're going to use. It's just going to be one of the ones we're going to have. The next one we can have is what is called dy dx. What that means is we're going to take the derivative of our function y with respect to x, is what that really means. D dx of f of x right here. This means the derivative with respect to x of our function f of x. It's just another way of writing dy dx, basically. The last type of notation is d sub x of f of x. That just means the derivative with respect to x of f of x. Another notation that you may see is fx, f sub x there. That just means the derivative of our function f with respect to x. We'll see a lot more notation like that later on in this semester in terms of our videos and everything. So we know that the definition of a derivative is f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all divided by h. We've seen that. We've been using it every problem here lately. Well, now we're going to jump to what we call the easy buttons. The first one we have here is our constant rule. If we have a function f of x that is equal to k, where k is any number, f of x equals 8, f of x equals 2 pi, neither one of those have an x in it. So what we're saying here is f of x equals 2 pi. What we're saying is f prime of x is equal to 0. Same thing for f of x equals 8 right here. Its derivative, f prime of x, is equal to 0. If it doesn't have an x in it, its derivative is 0. So we're going to start out simple, and then we're going to work our way up to more complicated derivatives in the next few sections here. The next one that we can talk about, which is probably, in my opinion, one of the most important rules that we can have for derivatives. It is probably the one that is used the most out of every single rule that we have, is the power rule. If we have f of x equals x to the n, then our derivative, f prime of x, we're going to take our exponent of n, we're going to multiply in front of our x coordinate there to get n times x, and then we're going to subtract 1 from our exponent to get n minus 1. Easiest way to do this is to work some examples so that way we can see exactly what's going on. So for this first one, f of x equals x squared. So the power rule said take our exponent, put it in front, take our exponent and subtract 1. So we get 2 times x to the 2 minus 1, which is equal to 2x. Pretty simple there. Moving to this next one, f of x equals x to the negative 2. So that means f prime of x would be negative 2 times x to the negative 2 minus 1. So f prime of x is equal to minus 2x to the negative third. Keep in mind, if you have negative exponents and you subtract 1, they get more negative. We got to remember that rule. If we have f of x is equal to x, that means x prime of x is equal to 1 times x to the 1 minus 1. So we have f prime of x is equal to 1 times x to the 0, but we know x to the 0 is 1. So our answer is just 1 here. If we have square root of x, the first thing we need to do there is we need to write this as rational exponents. So this needs to be written as x raised to the 1 over 2. So that means that f prime of x is equal to 1/2 x to the 1/2 minus 1, which is 1/2 x to the negative 1/2. We normally don't want to leave this as a negative exponent because they gave it to us in radical form. So this would be 1 over 2x to the 1/2, which would be 1 over 2 on the square root of x. That would be our f prime of x in this case. Just like right here, 1 over x to the 5th. This would be x to the negative 5th. So f prime of x is equal to negative 5x to the negative 5 minus 1, which is negative 5x to the negative 6. We could rewrite this as negative 5 over x to the 6th as our derivative here. For f of x equals 1 over square root of x, that is 1 over x to the 1/2, which is x to the negative 1/2. So its derivative, f prime of x, is negative 1/2 x, negative 1/2 minus 1, negative 1/2 x to the negative 3/2. And we would stop right here, 1 over 2x to the 3/2. There's no need to rewrite that in radical form and everything. We can leave it just like that and be fine. The next thing we can talk about is the rule for a constant times a function. So if you have k times f of x and you're taking its derivative, k is a constant, it's a number. So it's just a constant times the derivative of our function would be our answer in that case right there. So our first one here, f of x equals 4x squared. This would give us f prime of x is equal to 8x to the first, or 8x to the 2 minus 1, which is still just 8x. For the second one here, we could change to the minus 5x to the negative 1. So f prime of x would be 5x to the negative 1 minus 1, which is just simply going to be 5x to the negative 2, or if we rewrote that with a positive, 5 over x squared. For this next example, f of x equals negative 5x to the negative third. So f prime of x would be 15x to the negative 3 minus 1, which is 15x to the negative 4. So that would be our derivative. Now, it doesn't stop there. It wants us to find f prime of 6. So f prime of 6 would be 15 over 6 to the 4th, because we could have rewritten this as 15 over x to the 4th and everything. So when we do that, 15 divided by 6 to the 4th. So we end up with 15 over 1296. So when we do that, we end up with 5 divided by 432 as our answer here. The next thing that we can have is our sum or difference rule. So if f of x is equal to the sum or difference of any 2 functions, 3 functions, 4 functions, it doesn't matter how many functions. And we know that u prime of each one of our, or the derivative of each one of our functions exist, then f prime of x in this specific case would be u prime x plus or minus v prime of x, because f of x was equal to u of x plus or minus v of x. So to find our derivative here, basically the simplified way of what we're doing here is what that rule tells us is look at each individual term and do the operation on it by itself. So the derivative of 5x squared is going to be 10x. The derivative of 3x is going to be 3. The derivative of negative 6 is 0, so there's no need to write it. So therefore, our derivative is 10x plus 3. Just like before, when it talked about that we could find tangent lines and slopes of tangent lines, that's the applications we're going to be talking about for a while on our derivative. So we're told find the slope of the tangent line for y equals negative 8x to the negative 1 plus 5x to the negative 2 at the x value of x equals 2. So what we're looking for here is y prime is equal to 8x to the negative 2 minus 10x to the negative third. That is our derivative. So now the next piece is to use the x equals 2. So y prime at 2 is 8 times 2 to the negative 2 minus 10 times 2 to the negative third, which is really 8 over 2 squared minus 10 over 2 cubed. So we have 8 over 4 minus 10 over 8. So 2 minus 5 over 4, which gives us 8 minus 5 all over 4, or 3/4, as the slope of our tangent line. Notice it didn't ask for the tangent line, it asked for the slope, which is that's all we need to do there. Now, for what we know right now, there is nothing that we can take a derivative of if we have x's in the numerator and x's in the denominator. So what we have to do here is we need to rewrite this as 2x plus 7, and then we're going to divide each term by x to the 1/2 in each case, because we know the square root of x is equal to x to the 1/2. So when we simplify this, we're going to get 2x to the 1/2 plus 7x to the negative 1/2. I have not taken a derivative yet. This is still my f of x. I'm just rewriting it in a different way to make it easier. So if we were to take its derivative now, so we would have 2 times 1/2 x to the negative 1/2 plus 7 times negative 1/2 x to the negative 3/2. So we end up with 1 over x to the 1/2 minus 7 over 2x to the 3/2. So this one didn't tell us to find anything specific here because we didn't have an x value that was given. So therefore, this would be my f prime of x that we were looking for. So these directions tell us find all values of x where the tangent line to the graph of the function is horizontal. All right, so tangent line means we need to key in on derivative. So y prime is equal to 2x plus 2. Now the next part of this set, we start talking about horizontal and finding all our values of x. Well, don't let all these fancy words confuse us. We want to just plug it in, or in other words, in this case, we're going to set it equal to 0 and solve. So 2x equals negative 2, x equals negative 1. X equals negative 1 is the only value where our horizontal line is, where our tangent line is horizontal. We can also talk about business applications here. So first, it tells us finding the marginal cost. The total cost is C of x equals 9 plus 8x squared plus 4x cubed. Find the marginal cost at x equals 3. Marginal means derivative. So always keep that in mind. So C prime of x is equal to derivative of 9 is 0. 8x squared's derivative is 16x plus derivative of 4x cubed is 12x squared. Now this one also told us at the value of x equals 3. So C prime of 3 is 16 times 3 plus 12 times 3 squared. So we get 48 plus 3 squared is 9. 9 times 12 is 108. So we get 156 as our value. So that is the marginal cost or the change in cost at x equals 3. For our last example here, we're given a price function. P of x equals 150 over 7x plus 2134. Where x represents the demand for the product, we're told to find the rate of change of price when the demand is 5. So anytime that you see the word, rate, rate of change, you need to key in that you need the derivative. So P prime of x is equal to, easiest way to write this, so let me take off this prime real quick. P of x would be equal to 150 over 7 times x to the negative 1 plus 2134. So therefore, P prime of x would be negative 150 over 7 times x to the negative 2. Derivative of 2134 is 0. So we should get negative 150 over 7x squared. Well, now the demand is 5, so we need P prime of 5 is equal to negative 150 over 7 times 5 squared. So negative 150 over 25 times 7 is 175. 150 divided by 175 is minus 6 over 7. We normally do not leave our values like that. We would actually go ahead and divide this out. So this would give us approximately negative 0.86. That is the change in price whenever our demand is 5. Hopefully we are more interested in using our derivatives in this short, easy way compared to the definition, because you will see that you're going to need this for a while. So this is the best way to do it. Make sure you learn both ways though. Don't forget how to do the definition because you could see problems that will require that at some point.